In this video, I'm going to be discussing my solar ground mount system, how it was designed and how it was installed. But I'm going to start by explaining why I've chosen to use a ground mount system rather than simply adding more solar panels to the roof of my house. The solar panels on the third floor of my house aren't shaded in any way. Unfortunately, that roof is now full of panels, and any other panels I put around the house suffer from shading. A ground mount system has less shading and also benefits from better power output from the bifacial panels. So, how do we get from this to this? Fortunately for me, Tam, my solar guy, is particularly good at CAD, and he supplied me with a 3D computer-aided design program so that I could see what steel I needed and how it all fitted together. And I used this to order the steel I would need. Steel in Thailand is measured in meters in terms of length, then it's measured in inches in terms of width, and millimeters in terms of thickness. We ordered a variety of square and rectangular tubular steel, all 2 millimeters thick. The next problem was welding. I already owned a stick welder, which is the most common form of welding here, but for this job I bought a MIG welder as well. The MIG welder is the orange one, and behind it in white is the stick welder. And then you can see the jig that we used to build the trusses and ensure that they were a uniform size. The MIG welder uses a self-shielded flux core welding wire, which is a lot easier than gas. Here you can see the triangular steel truss roof supports that we fabricated. They're a highly rigid structural framework made for interconnected steel members arranged into triangles to distribute heavy loads across wide open spans. Attaching a column to a foundation through a base plate is where superstructure meets substructure. Base plates transfer the vertical forces of a column to the foundation over a larger area. The main load that columns see is axial, along their length, pressing the plate to the ground. However, horizontal forces from the wind can increase compression forces on one side of the base plate. They can also result in shear and tension forces between the base plate and foundation. So that is why the choice of anchor bolts is important. Base plates made of a single steel plate offer limited contact with the column. This is why I went for square post flange bases, which are factory welded. They feature a square inner socket to receive a square metal tube, all of which helps to resist shear forces. Another way to ensure an even transfer of forces into the substructure is by using grout to bridge the gap. Grout is basically concrete without the large aggregate. With a low viscosity, it flows more easily into the gaps. The grout helps to transfer and distribute the load into the foundation, ensuring that there are no gaps between base plate and concrete structure. Another way that we can help columns to resist horizontal forces is with bracing. So one question that I'm already getting is, why is there 3.5-inch tubular steel sitting edge on above the solar ground mount system? Well, the reason that is there is that Tam, my solar guy, has designed a bracket that fits onto that size steel that then clips onto the solar panels. I think it's going to be easier to see when the solar panels are installed. So if you are curious, I suggest you pop back and see my next video when the solar panels have been installed.